that we've determined how to identify some pieces to graphing rational functions, we're actually going to plug those into an x and y axis and plot those points. Before we even get into that, I want to talk about some scenarios that you might see, or some situations with rational functions. They kind of follow a pattern, and so if you know where holes and solutions are, you typically know where the rest of the graph is going to be without even looking at your graphing calculator. So if we have actually, we're going to start off with just one, so I got ahead of ourselves here. So if one vertical asymptote, then you really have two scenarios. Okay, so if you have one vertical asymptote, let's just say this is my first x and y axis, and this is my second. And so I'll draw in asymptotes wherever I want. Let's just put them over here, and then let's put one here and here. Okay, so it doesn't really matter where you draw them. You can draw them in the same place as me. You can draw them different. But there's really only two scenarios. You're going to see that our vertical asymptotes do not approach the same asymptote at the same time. So what I mean by that is if you have part of your graph that appears here in the bottom left-hand corner, I'm picking a different color here so this looks a little better. So if I have something in the bottom left-hand corner of this graph, with this being the top left, top right, bottom right, you're not going to see something right next to it. So there's nothing that's going to show up in the top left or the bottom right if you have something in the bottom left already. Your graph will end up being in the top right. Now this is for the scenarios that we're dealing with today. Yes, there are exceptions. Yes, graphs can do certain things, but for the graphs that we're going to see in this unit, they're typically going to be diagonal from one another. So if you have something in the top right, so let's say top right of your asymptotes here, then you are not going to see something in the bottom left or in the top right. Sorry, your graph here is in the top left. You're only going to see another piece of the graph, a diagonal from it, in that bottom right-hand corner. And so if you have one vertical asymptote, these are really the only two scenarios you could possibly have. Your graph will be bottom left, top right, or top left, bottom right. It won't show up next to each other. They won't be converging towards that same asymptote. So with that same idea in mind, we are going to look at what happens when there's two vertical asymptotes. So if there's two vertical asymptotes, we see a different scenario. So if two vertical asymptotes, we actually have a few more combinations because we have more things that can happen. So if there's two vertical asymptotes, you'll see a couple of different things. Alright, so I'm going to draw in two vertical asymptotes here. Two again, two again, and two again. So you have two scenarios for what could happen in the middle. And I'm just going to draw my horizontal right across the middle. So in between these two vertical asymptotes, you can have a parabola. And if you have a parabola, it kind of looks like this, right in the middle there. And then if the same rule holds true, you're not going to see two pieces of your graph approaching the same asymptote. So we're going to have that bottom left and that bottom right portion of your graph covered because we're not going to both converge towards that same asymptote. They won't approach it at the same time. And so if you have a upside down parabola or a negative parabola in the middle for your scenario number 2, then you will have something in the top left and the top right. Again, they're not going to be approaching right next to each other. They'll always have this diagonal approach. So if we don't have a parabola in the middle, we actually have a cubic in the middle. And our cubic takes on two different forms. So first off, a cubic is allowed to pass through the horizontal asymptote. A lot of times you will have a hole at that value, so there actually won't be a portion of the graph there. But it might look like this, where you have a cubic that goes up on the right and down on the left. If that is the case, that rule still applies, that our graph will not approach the same asymptote. So on the top right here, because we are approaching this asymptote that is on the right, we will not have anything in the top right portion of our graph. What we will have then is something in the bottom left portion of our graph. And then, in the bottom right portion of our graph. Over here, we are approaching this asymptote down here, so we will not have a portion of our graph approaching this bottom left corner. We will in the top left corner though, because our cubic is not approaching this top part of our asymptote. They're not both converging towards that at the same time. You can see that both of them are kind of going to the right here. Now if we have a cubic that's flipped, or it's going up on the left and down on the right, or a negative cubic, then the same thing applies. We will not have anything in this top left because then our graph would be approaching this same first asymptote. So instead we have something in the bottom left. And then if we look at this piece over here, we're either in the top right or bottom right. Hopefully by now you can determine which portion of your graph you're going to be graphing in. Not that bottom right, because that'd be converging towards the same asymptote, but in the top right, we will have a piece of our graph. So these are your 4 scenarios when you have 2 vertical asymptotes. We won't have more than that, at least for our purposes. So the yes, more can exist, but we're only going to be graphing ones like this. But for our first example here, we're going to take a look at graphing what we know. So we've got a function f of x is equal to x minus 2 over 2x plus 8. So I'm going to factor when necessary. In this case, I can factor the denominator, 2x plus 4. All right, so we're going to identify all of our key information. We've got our vertical asymptote. That is at x is equal to negative 4. We've got a horizontal asymptote. In this case, we have a degree that is equal heavy. We have a degree of 1 and a degree of 1. So we're looking at those coefficients. We have a 1 in front here and a 2 here. So y equals 1/2. So we're going to graph that at 1/2. We do have a solution of 2, 0. And then we don't have no hole in this case for right now. We'll get to holes a little bit later. So we put all these pieces in our graph. We have a vertical asymptote at negative 4. 1, 2, 3, 4. Vertical asymptote right there. And then we have a horizontal asymptote at 1/2. So kind of find halfway and graph that. Now remember that x equals tells you that you're going to have something that passes through the x-axis, and y equals tells you you will have something that passes through the y-axis. So keep that in mind. Now we are going to have a solution at 2, 0. So 1, 2, 0. It appears right here. All right, and so now just based off of what we know about how rational functions operate, we see that we have a value in the bottom right-hand portion of our graph. And so that means that we're going to have the rest of our graph that follows suit. So it'll look like this. And we know that there's nothing going to be in this top right, nothing in this bottom left, so the other piece of our graph has to be in the top left. You don't have to worry about exact values, except for your solutions or your holes. That's the only thing you have to be precise about. As for these, you can just kind of draw a rough sketch for the rest of your graph. It's going to be f of x is equal to 4x plus 8 over x squared plus x minus 6. So again, we want to factor everything that we can, see if anything cancels. Take out a 4, get x plus 2, and get x plus 3 and x minus 2. So nothing's going to cancel here. So we don't have any holes in our graph. So we'll start off with our vertical asymptote. There's actually 2 here. So we have x is equal to negative 3 and x is equal to 2. Our horizontal asymptote, we have bottom heavy with degree. The numerator is 1, denominator is 2, so then automatically y is going to be equal to 0. And we do have one solution for our graph in this case, and that's going to be at negative 2, 0. So when we plot everything that we know that we have an asymptote at negative 3. We know that we have an asymptote at 2. We know that we have a horizontal asymptote at 0. And we have a solution at negative 2. Now, since we have a solution at negative 2 and a horizontal asymptote, that should be an indicator to us that we are going to have a graph that passes through the horizontal asymptote. Because you have a solution and an asymptote that's kind of counterintuitive. So at this point, I would want to go to my graphing calculator and take a look at this and see what it looks like. So I'm going to give you a second to type this in. I would type in the original one, type in parentheses around it, both the numerator and denominator, so you can see what that looks like. At this point, when you type this in your calculator, you should see that this appears to go this way. So that means you're not going to have anything in the top left. You'll have a graph in the bottom left and the top right for your finished graph there.